In this video, you will learn why soils change volume during the construction process. Let's take a second to look at why this topic might be important to your career. Soil is a pretty unique building material in that its volume changes whenever it is moved from one location to another. We refer to this as the shrink and swell of the soil. If you, as a construction manager, don't understand and plan on these volume changes, you could find your project cost increasing unexpectedly. In order to understand the shrink and swell behavior, we need to understand the composition of any soil. As we see here, all soils have three components: air, water, and solids or soil grains. This diagram shows us the solid grains and then the spaces between the grains, which is called the void or pore space. This void space is filled with some combination of air and water, as we can see here. A phase diagram like this on the right is another way to visualize the soil matrix. Like all construction materials, there is a standard unit of measure for soils, and that is the cubic yard, abbreviated CY. If we think about all the possible locations for soil on a construction site, looking at the diagram, we can see that there are really only three places. And these terms, by the way, are industry accepted terms. And those locations are the bank, the loose, and the compacted cubic yard. Let's consider first the bank or cut. This is the area where an excavation will be made. Up to the time of excavation, this is undisturbed soil, essentially where nature put it. The term BCY, or bank cubic yard, is used to identify all soils in this location. Our next possible location is in the hauling unit, which is just another term that would include trucks, scrapers, loader buckets, or anything else used to transport soils from one location to another. In the process of excavating and placing soils into a hauling unit, the soils are loosened or fluffed up. Soils in this condition, after being excavated, are called LCYs, or loose cubic yards. This would also apply to soils that were excavated and temporarily stockpiled for later use. The last of our three locations is soil that has been placed in a fill area and compacted. As you might expect, this is called a CCY, compacted cubic yard. Okay, to recap what we have learned so far, soil is a matrix of air, water, and soil grains in some proportion. Soil will be found in either the bank, BCY, hauling unit, LCY, or compacted CCY location. Let's consider the swelling part first. As we said, in the process of excavating soil from its natural position, the bucket of the excavator will loosen the soil up and add more void space in the process. In this example, we can see that 1 BCY becomes 1.25 LCY during this excavation process. And why did this happen? Well, as we just mentioned, in loosening the soil, we're increasing the void space. So in terms of our phase diagram, the void space grows. Now always remember that this is just a temporary condition, this LCY, and that it ends once the soil is dumped and compacted. Okay, so that is swell. Let's consider how shrinkage works. Here's the deal. Soil ultimately decreases in volume from cut to fill. That is, from BCY to CCY. To me, it's always been interesting that as contractors, we actually improve soils for construction by making them more compact. That is, denser and stronger than they were left by nature. As we might expect then, soil also shrinks even more from the LCY state to the CCY state. Looking at the numbers in the illustration, and they are just examples, we find that from BCY to CCY, this soil is shrinking about 10%, and from the truck, LCY, to the fill, CCY, about 28%. And once again, why did this happen? Because the process of applying compactive energy, represented by your compactor in the illustration, actually pushes the soil grains closer together and that reduces the volume of the void space, as we see in our phase diagram. So the big, not to be forgotten takeaway here is soil always shrinks from both BCY and LCY to CCY. And let me just put a plug in here. There will be another separate video dealing specifically with soil compaction. Okay, some management implications then. Let's look at what we have just learned in the context of a project. Remember, we said at the beginning of this that the construction manager needs to understand shrink and swell in order to avoid project surprises and cost overruns. In terms of the total earthwork on any project, one of three things will happen. The first would be what we'd call a balanced site. That is, that the total BCYs excavated would satisfy the CCYs when compacted. In other words, fill plus shrink would equal cut. And we know that due to shrinkage, we will be excavating more BCYs than the fill or CCY volume required, because the BCYs shrink when compacted into CCYs. Another possibility is that the site will either have more soil than needed or not enough soils. When this condition occurs, the contractor will normally be using highway-type dump trucks to either export or import the additional soils. Keep in mind that dump trucks can carry only LCYs, and that the payment for the hauling is normally on an LCY basis. Just an experience-inspired footnote here. When hauling in dump trucks, the volumes that are normally agreed to are usually somewhat overstated in addition to being in LCYs. So let's consider a project that has extra soil after all the fills have been built. We would refer to this as an export or waste project from an earthwork point of view. So when planning for this type of work, we need to keep in mind that the soil will swell as it is loaded into the dump truck. So the volume we will be paying the trucker for will be greater than the volume we excavated. Why? Because soil swells from BCY to LCY. Now, what if we don't have enough soil on the site? This, of course, would be called an import or borrow job. And we also know that we will be purchasing more LCYs, that's in the dump truck measurement, than the CCYs required. Why? Because the LCYs will shrink when compacted into CCYs. Is there a standard amount that soil will shrink or swell? Unfortunately, the answer is no. There are a wide variety of soil types. There's different soil moisture contents. There's different size compactors and compactive energy. And all of these things really rule out one common shrink or swell factor. That said, I've shown you some general ranges here, but keep in mind that each project's soils must be individually evaluated by an experienced person to accurately predict shrink and swell for that particular project.